Example 21.4 says find the exact solution of each equation, and then the phrase be sure to reject any value of x that is not in the domain of the original logarithmic expressions, then use a calculator to obtain a decimal approximation. So this set of examples is not going to be set up nicely to where the one-to-one property would apply. So the one-to-one property for logarithms and the one-to-one property for exponents are very special cases of equation. Not every equation is going to fit that profile. So when they don't fit that profile, then you have that equivalency definition for log and exponent that you can use to be able to convert from one form to the other. So that's what we're going to do here with part A. It says log base 5 of x is equal to 3. So if I convert this to exponential form, my base will be 5, the exponent is 3, and it's all equal to the argument, which is just x. 5 to the third is 125, and so then I get the statement 125 is equal to x. And there is zero problem with taking 125 and substituting it back into the original equation. So therefore, our answer must be 125. Part B, same idea. I have log base 7 of x plus 2 is equal to negative 2. So if I take the base 7, raise it to the negative 2, this is going to be equal to the argument of x plus 2. In which case, to finish solving for x, I'd want to subtract 2 from both sides. So 7 to the negative 2 minus 2 is going to be equal to x. So I'll interpret the 7 raised to the negative 2 as 1/49th. And then to subtract 2, we would need to get a common denominator to be able to combine those two terms together, and that'll end up being negative 97/49. And that would represent the exact answer. The decimal approximation for that is negative 1.980. That's an approximation again. Now if I take that value of negative 1.98 and substitute it in to the argument, I have to add 2 to that x value. And if I add 2, it's going to make the argument just a little positive. And all it takes is being a little bit bigger than 0, and we say that it is a perfectly acceptable argument. So we're going to get the check mark on that, and therefore we will box in both the exact and the decimal approximation. Now I didn't bother with a decimal approximation on part A because 125 is just a whole number. There's really nothing to approximate there. The answer is fine as it is.